Hey folks, starting out 4.3, there's just two videos here, and the topics are pretty small. There's only one idea that we're going to cover today, and that is classifying collisions as elastic or inelastic, and working with elastic collisions specifically. The truth of the matter is that I kind of fed you a lie earlier in the unit, and we talked about inelastic and elastic collisions being sticky collisions where objects stick together, and elastic collisions being bouncy collisions. Now that's generally true, but in this video we're going to talk about how there's a continuum of collision. At one end we have inelastic, at the other end we have elastic, and in between is essentially some mix of the two. So we'll talk about two different aspects here. So completely inelastic and completely elastic are extremes. Now the first thing we're going to do is we're going to divide this continuum right there. And if we say that a collision is completely inelastic, that is when the objects actually stick together. And that's a very small part of this continuum. And so there's like a lot of other situations where there's an inelastic portion to the collision, but they don't actually end up sticking together. And then every other section of this continuum is when objects bounce. And the degree to which they bounce off one another determines where they are in this continuum. This completely elastic is like a perfectly bouncy collision where there's no deformation of anything. And then anywhere else along the continuum, there's like increasing degrees of deforming of the objects and partially sticking before separating. So in summary, when we say completely inelastic, that's when we mean the objects stick together. All other collisions that involve objects bouncing off are some degree of elastic and inelastic. All right. So the second way we're going to divide this up is at this border, and we're going to separate out completely elastic. So for completely inelastic and everywhere else along the continuum until you get here, some energy is lost or stored. Our energy unit will help us determine maybe whether the energy is lost or stored, but basically it has to do with like what type of energy gets created in a situation where kinetic energy is lost. And that's actually worth pointing out, that this energy is kinetic energy because the objects are moving and then collide. When we say completely inelastic, we mean that the objects bounce off one another and the total kinetic energy is constant. So to say completely elastic for a collision is to say that your collision obeys two conservation laws: conservation of mechanical energy and conservation of momentum. Now, completely elastic collisions happen very infrequently. In order for that to actually happen, an object has to have no internal structure. As soon as you have parts that can move or jiggle or whatever, kinetic energy is lost. So really, when we say completely elastic in a strict sense, we are talking about essentially electron clouds colliding with one another. One electron meeting another electron in like a particle accelerator and bouncing off one another. Even something like a proton, which does have internal structure, if you collide two protons, there's going to be some kinetic energy lost. The more complex the objects, maybe the more kinetic energy is going to be lost. As you get into objects that we use in the room, the materials they're made of will determine how much kinetic energy is lost. Anyway, so that's the distinction. Completely inelastic is the situation where objects stick together, and completely elastic is the situation where energy is conserved in addition to momentum. So the final question is like, what's your responsibility with this concept? Really, the responsibility is if a collision is identified as completely elastic, then you have to understand that there's two conservation laws that are being obeyed. Linear momentum is constant throughout the collision, as is total kinetic energy. I'm not going to write anything else besides these equations, so if you aren't using the note sheet, just copy them down. If you are, just enjoy that they're written for you. The total momentum is the same throughout, so if it's elastic, then they are separate at all times before and after the collision. And then as far as kinetic energy is concerned, they're also separate. And just like in another physics class, you might be expected to solve a system of equations like this, where there would be two unknowns, one for the final velocity of the first object and then the final of the second. At most, in this course, you'll be expected to write out the two equations to show how kinetic energy behaves. So if an object is ever at rest, you can cross out that term. If the masses are identical, you can use the same variable, etc. And just understand that there will be no loss of kinetic energy, no gain of kinetic energy. You might have to apply conservation of energy in a very simple way if you know the speeds of three, if you know three speeds, you can use either momentum or energy to do that. So really that's it. The problems that I am going to have you do in the next video are related to this, but might not completely overlap with this concept. Thanks.